So now looking away from the math of KEQ and looking towards the actual analysis of it, KEQ can actually tell us about a chemical reaction. If KEQ is large, and if we think about the math, because KEQ is the products over the reactants, in order for the math to work out that KEQ is large, the concentration of the products must be bigger than the concentration of the reactants. And when I say large, I mean anything greater than 10. In this situation, almost all of the reactants get used up or they get consumed, and a large amount of products gets formed. This is exactly like the first example when we had H2 and I2 forming HI. At the end, there would be a lot of HI and not very much H2 and I2. Second situation, if KEQ is very small, the math would have to be that the reactants are much greater than the products. And when I say small, this is a KEQ of something less than 0.1. Now the last example involving methane, ethine, and hydrogen, KEQ is 0.15. So it's small, but it's not very small. Sometimes we'll have KEQs that are 5 decimal places deep. In those cases, very little of the reactants get used up, so there's very little products formed. Third situation, when KEQ is basically Goldilocks, it's just right. Somewhere between 0.1 and 10, in this situation, there would be roughly equal amounts of products and reactants. Obviously not exactly equal amounts, but close enough that we can call them roughly equal. This way, in this kind of reaction, the chemical reaction would go about halfway through. If we want to go back to that elevator analogy, the very large KEQ is you've walked almost all the way to the other end of the elevator before you start walking back. KEQ being very small, you've started walking backwards on the first couple of steps. And KEQ in the middle, you've gone halfway down the elevator, and then you start walking and you stay right in the middle.